Hello, great mathematicians. Welcome back to our series on matrices. This lesson, we are going to look at something very important, that is inverse of a matrix. But before we can look at the inverse of a matrix, please, first of all, subscribe and turn off the notification button for updates on all the videos or the lessons that are going to be coming in anytime. So for today we are going to look at inverse of a matrix, but I'm requesting that let us spend some 5 or 4 to 5 minutes, it can even be 3, talking about a singular matrix. I know that there are people who need more about that. We are just going to look at just one more example, then I leave you with some trial number, then we go to inverse of a matrix. Okay, so let's have this example. We are given that matrix B is equal to that, but this matrix is a singular matrix. Then they are telling us to find the value of A. So here we have an unknown A. This is a 9. This is A. So we're having A, 4, 9, 12, and the question is telling us that this matrix here is a singular matrix. So by telling us that it's a singular matrix, then its determinant is 0, meaning that determinant of B is equal to a 0. So if I'm to get the determinant of B, which we also get as A, remember I've said it is a 0, but this one is still equal to the product of the terms in the leading diagonal, which is 12A, minus the product of the terms in the minor diagonal, which is going to be 9 times 4, which is going to give us a 36. Okay, so I have a 0, meaning that 12A minus 36 is equal to a 0. 12A is equal to 36, meaning that A is going to be a 4. That's the only concept that I wanted you guys to emphasize more, and you can be able to understand it. So whenever you are given any question of this form, please go ahead and remember the concept of a singular matrix, that its determinant is always going to give you a 0. So I'm going to leave you with a very simple exercise on that. Then we continue with our major aim for today, which we want to look at, that is the inverse of a matrix. So let's have that simple easy exercise for serious students. Given that P is equal to 1, 2, 4, 3, and Q is equal to 5, 1, 2, X. Okay, find the determinant of P, part B. If the product PQ forms a singular matrix, find the value of X. Oh yes. Should I give you a hint, guys? Yes! Okay, I had that. Now, what you're going to do here, first of all, look at the question, what it is requiring. For the first part, that is very easy. Use the definition of a determinant of a matrix. You'll be able to define the determinant of matrix P. Then for the second part, first of all, form a matrix PQ by using the concept of multiplication of matrices. Then the matrix you form, you use now the concept of a singular matrix. Then you'll be good to go. Okay, that is it. The answer you'll get for X, it will be 10 over 25. Yeah, 10 over 25, that's around 0.4. yeah, 0.4. so that's what you are going to get for X. Then let's continue. Let's start what we promised to do in this video. I have promised that we are going to look at inverse of a matrix. So our topic for today, our major concern for today, is the inverse of a matrix. Like last time I told you that we need to consider the 2 by 2 matrix. We should restrict ourselves to a 2 by 2 matrix, meaning that still the order of the matrix that we shall be dealing with will be a 2 by 2 matrix. At this level, we need not to go deep into maybe a 3 by 2 or a 3 by 3 matrix. So we shall restrict ourselves to a 2 by 2 matrix at this level, meaning that for members who have not yet understood or who don't know what the order of a matrix is, please, you should go back and visit our videos. You look for the lesson where we are describing the different terms that we use when you are describing matrices, or when we are dealing with matrices, such that you can be able to understand the order of a matrix that we shall be talking about. So inverse of a matrix, I'm just going first of all introduce it. I'll give you a simple hint, something very small on the inverse of a matrix, such that you can be able to understand what you shall be looking at. We shall use two methods when we are finding the inverse of a matrix. The first one will be using the definition of the inverse, but before we look at the definition of the inverse of a matrix, let's first of all look at something very small. I can call it introduction. Let's look at something very small. If A is a matrix, that is a 2 by 2 matrix, because we are restricting ourselves. If A is a 2 by 2 matrix and I is also a 2 by 2 matrix, I, remember, I is an identity matrix. Then if A is a 2 by 2 matrix and I is also a 2 by 2 matrix, this simply implies that if I get I, the identity matrix, I multiply it with A, it should give me A multiplied with the identity matrix. This should give me A. Remember, I told you that for matrices, A multiplied by any other matrix cannot be the same as that matrix multiplied by A. If I have a matrix A, I multiply it by matrix B. This one is not the same as matrix B multiplied by matrix A. It is only true when either of these matrices is an identity matrix. So if this is not an identity matrix and this is also not an identity matrix, then this is true. They cannot be the same. But so long as one of the matrices is an identity matrix, then this one becomes true, meaning that A multiplied by I is the same as I multiplied by A. Since I is an identity matrix, so this one will still remain the same matrix because this one is an identity matrix. It's like having a 1 multiplied by A. Still, you'll still have A multiplied by 1. It's the same thing. Still, it will give you A. So that is the identity matrix. Okay, so that's what we want to base on. We want to base on this definition here, or on this statement here, to look at an identity, to look at the inverse of a matrix. Sorry, so we need to base at this definition and we look at the inverse of a matrix. Before we can go further, let's first have a simple example there to verify this. Let me write it here. I think the space will be enough for me. If I have a matrix A as 1, 4, 3, 10, then the identity matrix, of course, this one is 1, 0, 0, 1. Okay. Now, if I'm to consider the above matrix there, I'm going to have A, I as 1, 4, 3, 10 multiplied by the identity matrix, which is 1, 0, 0, 1, which is going to give me row by column. If I'm to multiply row by column, it is this row by this column. So it is 1, okay, times 1, okay, plus 0. Then I go here. Then this one is going to become 1, which is a 0, a 4. Okay. Then this one is going to become, I go down, this with this. So this is a 3, 0. So I have a 3. Then 0 plus 10, which is 10. So the matrix that I form is that. Hope that is clear. Meaning that if I have an identity matrix and I multiply it with any matrix, it will still give me that matrix. This one is the same as IA, which is also the same as A. Hope that is very clear for all of us. So implying that our definition there, or our condition there, is still holding for that. So let's have a definition of an identity matrix and be able to see what an identity matrix really means. The inverse of a matrix A is a matrix A inverse, or A power -1. So the inverse of A, I'll write it, it is denoted by that. So this is how it is denoted. So the inverse of a matrix A is a matrix A inverse such that A multiplied by A inverse gives you A inverse multiplied by A, which will give you an identity matrix. That is the definition of the inverse of a matrix, meaning that to get the inverse of any matrix, I have to multiply that matrix by the inverse to get an identity matrix, to prove that it is really the inverse. Hope that is making some sense. So meaning that the inverse of a matrix, in other words, it is that matrix which, when multiplied by the matrix you have, gives you an identity matrix. The inverse of a matrix B is any matrix which, when multiplied by B, gives you an identity matrix, meaning that if I have the inverse of B as Q, if I multiply B by Q, I have to get an identity matrix. If I have a matrix Z as the inverse of B, it implies that if I multiply B by Z, I should get an identity matrix. So the inverse of any matrix is that matrix which, when multiplied by the matrix at hand, or the matrix that we are having, gives you an identity matrix. Hope that is very clear for all of you guys. Let's have a very simple example. Find the inverse of matrix A, which is 8, 3, 5, 2. So that is the matrix we are given. Let's see, first of all, remember our definition that we have already described above, that the inverse of any matrix is a matrix which, when multiplied by the very matrix, is an identity matrix. So the inverse of A inverse, when I multiply it with A, I get an identity matrix. So that's what we are going to do. So the first step here is let the inverse of A to be a matrix which has unknown entries. Then we are going to multiply these two matrices A with the identity, with the inverse, its inverse. So the matrix A is 8, 3, 5, 2. I multiply this matrix with its inverse, which I don't know the entries, and I'm going to find them. It should give me an identity matrix like that. So from here, I go ahead and do the usual matrix multiplication that we have been dealing with, which we said that it is the row multiplied by the column, a row multiplied by the column. You go down, this row multiplied by that column, this row multiplied by that column, and that one is going to give us 8 multiplied by A. 8 multiplied by A, it will give us 8A, plus 3 multiplied by C, which will give us 3C. I go to the next one, which is 8 multiplied by B, which is 8B, plus I get 3 multiplied by D, which is 3D. I go down, still the same thing, 5 multiplied by A, which is 5A, plus 2 multiplied by C, which is 2C. The next one is 5B plus 2D, should give me the identity matrix this side. Then from there, I want you to realize something, that these entries are going to go with the specific entries from the left hand side and the right hand side. This entry here at this position will go with the entry which is in the same position but on the other side. The entry here will also be with the entry which is on the other side, but same positions. The entry here, we shall also match it with the entry which is the other side. The entry here, we also match it with the corresponding entry on the other side. So this will be equal to 1, this will be equal to a 0, this will be equal to 0, this will be equal to a 1. Then we form equations and solve those equations simultaneously. So that's what we are going to do. We are going to get an equation which is 8a plus 3c should be equal to a 1. Let us call that equation 1. Then we are going to form this with this. 5a plus 2c should be equal to a 0. Okay, this with this, this with that. So we get 5a plus 2c is equal to a 0. Okay, if I am to equate this with that, I form that equation. Then this with that, still I form that equation. I call it equation 2. Then we go to the next one, which is going to be 8b plus 3d is going to be equal to a 0. So 8b plus 3d is going to be a 0, and I call that one equation 3. Then I go to the next one, which is going to be 5b plus 2d is equal to a 1. So it is 5b plus 2d is equal to a 1. Hope that is clear. I call that one equation 4. As simple as that. Then from there, after forming my 4 equations, I select the equations that are similar. You look at equations whereby I can solve this equation with this equation simultaneously. For example, those equations which have similar unknowns. For example, this one has a and c, this one has a and c, this has d and b, this also has d and b. So I can solve the other equations separately. I also solve these equations separately, but I solve them simultaneously. So I'm going to solve these 2 equations simultaneously. I can either use elimination method, or I can use substitution method. You can use a method of matrices. We have not yet covered that yet. We shall look at that. You can use graphical method to solve those equations simultaneously. But for this case, we are going to solve them using elimination method. So we are going to just eliminate some of the terms, then we do back substitution to get the answers of the other equation. So if I'm to solve equation 1 and 3, whereby I have a and c, I'm going to have 8a plus 3c equaling to a 1. Then I'm going to have down 5a plus 2c is equal to a 0. So if I'm to look at this, I want to eliminate either a or c. So I can eliminate c, that would be easy for me. If I'm to eliminate c, I'm going to multiply this equation by 2 and multiply this equation by a 3, such that if I multiply here, I get a 6c, I get a 6c, and I subtract those 2 equations, then c will go off. So the equation I'm going to have here is going to be 16a plus this one is going to be 6c is equal to 2. This is going to be 15a plus this is going to be 6c should give me a 0. Then I can subtract this equation minus this equation. Okay, so this is not a negative, it is 16. Okay, then if I'm to subtract this minus this, you can see that 6c is going to subtract 6c, and I will have a 0. So I will remain with a only. So I'm going to have a, that is 16a minus 15a should give me 2 minus a 0, which is going to be a 2. Then I get this 2 here. I substitute it back substitution in any of these equations. If I substitute this 2 in equation 2, I'm going to have 10a, okay, 10a plus 2c. I take the 2 to the other side, it becomes negative 2c. Then 10 divided by negative 2, that is going to give me c as negative 5. So meaning that the values of a and c are negative. A is 2 and c is negative 5. So that's what I'm going to have for that. Then let us solve the other equations also simultaneously. So if I'm to look at that, I'm going to have 8b plus 3d is equal to a 0. 5b plus 2d is equal to a 1. So I can also eliminate a d here. That is the easiest. I multiply this equation by 2. I multiply this equation by a 3. If I multiply this equation by 2, I'm going to have 16b plus, I multiply, that is 6d, should give me a 0. This one is going to be 15b plus, I multiply, this is going to be 6d, which is also going to give me a 3. Now, I can still subtract this equation minus this, which is going to give me b, as this is a 0. 0 minus 3, that's going to give me negative 3. So the value of b is negative 3. Then I substitute b back in either of these equations. I can substitute it here. If I substitute it here, that is negative 15. Okay, negative 15. I bring this one this side. That's going to give me negative 16 plus 2d. I take the 2 to the other side. So it's going to give me negative 2d. I divide, then that's going to give me something like 8, meaning that d is going to be 8. So after finding the unknowns from the equations that you formed, you bring back the matrix that you formed. So remember, we said that let the identity, the inverse of a be this, meaning that therefore I'm going to conclude and say the inverse of a is going to be, where I have a, I put the value of a that I got, which is a 2. Where I have a b, I put the value of b that I have got. Where I have a c, I put the value of c that I got. And where I have a d, I put the value of d that I have got, which is 8. As simple as that. So we can solve the inverse for the inverse of a matrix by letting that inverse and using the definition of the inverse of a matrix. I think we should do another example on that before we can look at the second method, whereby we use inverse of a matrix we get the inverse of a matrix, by getting the determinant and the adjoint of that matrix. Okay, I'm going to write another example and we see what we shall get. Okay, the example is example find b inverse given that b is that. So we want to find the inverse of b given that b is that. So from the definition, remember we said that to get the inverse, I multiply the inverse by the matrix, then it should give me an identity matrix. So if I let my inverse to be, this time let us let some other values, maybe x, y, maybe z and w. Let us use these ones and see. Please let any unknown you want. Don't be restricted to any number. Use any unknown of your choice. So meaning that if I multiply this matrix that I let by b, so I'm going to have b, which is 3, 6, 4. I multiply it by its inverse, which I don't know yet. I only know these unknowns which I need to find should give me an identity matrix like that. Then I'm going to still do the same thing. I multiply the rows and columns of these matrices. So row by column, which is going to give me 5x plus 3 times that, which is 3z. Go the other side, it is 5y plus 3w. I go down to 6x plus 4z. I go to the other one, it is going to be 6y plus 4w. This one should give me 1 0 0 1. Still, we are going to do the same thing to form the equations from this. If we are to form the equations from this, we are going to have this entry should be equal to that entry from the left and right hand side. So this entry should be equal to that entry, this entry should be equal to that, this entry should be equal to that, and this entry should also be equal to that. So it implies that the equation as 5x plus 3z as 1, I can call that equation 1. Then 6x plus 4z should give me a 0, that is equation 2. Then I go to this, which is 5y plus 3w should be equaling to a 0. Then 6y plus 4w should be equaling to a 1. This is equation 3 and this is equation 4. So from there I can solve these equations simultaneously. So if we are to solve those above equations simultaneously, we are going to have this equation with this. So I'm going to have 5x plus 3z as 1, then 6x plus 4z as a 0. Then I can use elimination method or substitution or any method you know so far on solving simultaneous equations. So if I'm to solve this simultaneously, I'm going to eliminate something. I can decide to eliminate a z, maybe. If you want, you can eliminate x, but eliminate the easiest, which is going to be z in this case. So I multiply by 3 down, then up I multiply by 4. So if I'm to do that, this one is going to give me 20x plus this is going to become 12z, should give me a 4. This is going to be that is 3 times 6, which is going to give me 18x plus this is 12z, should give me a 0. Then I can subtract these two equations. If I subtract them, I'm going to have this is 2x, this one goes, is equal to 4. X is going to become a 2 if I divide by 2. Then from there I can substitute back this 2 in any of the equations I have there. If I decide to substitute it here, I'm going to have if I substitute x here, I'm going to have 12. Okay, this is 4z, so 12 plus 4z is equal to 0. I take the 4 the other side, so it is going to be 12 is equal to negative 4z. I divide by 4. If I divide by 4, 12 divide by 4, then I'm going to have something like negative, because this one goes with a negative, so z is going to be negative 3. Then from there I can solve the other two equations simultaneously also. So I solve these equations also simultaneously. I'm going to have 5y plus 3w is equal to 0, 6y plus 4w is equal to 1. So I can still eliminate the w here. I multiply this equation by 4 and I multiply this equation by a 3. So if I multiply by 4, I'm going to have 20y plus, I multiply, that is going to give me 12w should be a 0. Then this is going to be 18y plus 12w should give me, this one is going to be a 3. Then I can subtract the equations. If I subtract, this one is going to be 2y, then this is a plus 0, of course 12 minus 12, that is a 0, should be equaling to 0 minus that is negative 3, meaning that the value of y is negative 3 divided by 2. Then from there I can find the value of w. I substitute this back in one of the above equations. I can decide to substitute it here and get that answer. If I substitute it here, I'm going to have the value of w as that is going to be 10. Take the 3D aside, so the value of w that I will get in this case is going to be 5 out of 2. This therefore implies that the inverse of the matrix B is going to become, remember we said that let the inverse be x, y, z, w. So the inverse is going to become, I'm going to look for the different positions where I have x, I put the value of x, and the value of x we got a 2. Where I have z, here I put the value of z, which is negative 3. So here I put negative 3. And where I have y, I put the value of y, which is negative 3 over 2. Then where I have w, I put the value of w, which is 5 over 2. So this is what I will have for that. Now I'm going to stop here for today. At the end of this course, I'm going to provide you guys with a lot of questions. I will leave very many numbers such that you guys can do enough practice. I'll leave enough numbers for you guys to practice. For now, let us stop here. But please don't forget to do this subscription, then notification. Hope that is clear. Thank you very much for watching.